This is the video on area of regular polygons. I underlined regular because if you remember back in Geometry A, we decided that in order to be regular, all the sides had to be congruent. And all the angles on the inside had to be congruent. That's important to remember. Area for a regular polygon is area equals 1/2 lowercase a, and this little a stands for apothem. It's the distance from the center to the midpoint of an edge. And then notice it's a capital P. Remember, with these formulas, there's a difference between capital and lowercase letters. This is a capital P, which stands for the perimeter of the whole figure. So when you see capital letters, it's referring to the whole entire figure. So down here, we have a regular polygon. I know it's regular because all the sides are marked congruent. And if you notice, I have two things highlighted. Well, one thing here, and then here's another line here, which we're going to highlight in yellow. The apothem is the distance from the center. So here's the center of our polygon to the midpoint of an edge. That means this is congruent to this. This right here is the apothem. I also have another thing drawn on here in yellow. That's right here. And this right here is not the apothem because if you notice, it does come from the center, but here it's at a vertex. It's at a corner. So that is not the apothem. This is called the radius. And this one over here is the apothem. So when you're calculating the area, you have to make sure you're using the apothem to figure out your area. So here we have a regular polygon. We know it's regular because all the sides, once again, are congruent. The formula is area equals 1/2 times the apothem. So you want to look up in your picture and you want to make sure whatever segment you're looking at goes from the center to the midpoint of an edge. So in this case, our apothem is 4. And then the perimeter, so our capital P, means that we have to add up all the sides. So one length is 10. So this is 10, and this is 10, 10, and 10. And that's what happens in a regular polygon. So the perimeter, you can either go 10 plus 10 plus 10 plus 10, or you can take side length and multiply by how many sides there are for your perimeter. So we could take 10 times, we can see here we have 5 sides, equals 50 for our perimeter. So in my formula, I'm going to plug in 50 for my perimeter, or my capital P. So here we have 1/2 times, my apothem was 4, times 50. So half of 4 is 2, times 50 equals 100. So the area of this regular polygon is 100 units squared. Here's another regular polygon. All the sides are congruent. So the formula again is 1/2 times the apothem, we can see up here, times the perimeter. So if I look at my picture and I look at my segment in the middle, right here, this starts at the center, but it goes toward the corner. So we know we can't use that as our apothem, that's actually the radius. So this is not our apothem, so what we have to do is draw a dotted line and create your own apothem. So we could draw a dotted line right here and create our little 90-degree angle. I don't know the length of it yet, so I can call it x. We don't know the length of our apothem. But what we do know is that all the sides in this regular polygon have a length of 6, which means from here to here must also be 6. The things with the regular polygons, the apothem actually does two things. It comes from the center and it is the midpoint of a side, which means even though it is not marked, this has to be congruent with this. So this is 3 and this would be 3. So if I want to solve for my apothem, if you see this right angle here made by my apothem, the radius and half of this piece, I can set up the Pythagorean theorem by doing. That means the apothem is, let's figure it out, you would put x squared plus 3 squared equals 10 squared. And when we solve for that, we would find that x equals the square root of 91. So now I can set up my area of the polygon. Area equals 1/2 times the apothem, which we figured out to be the square root of 91, and then times the perimeter. So remember, perimeter is adding up all the sides or taking one side, which is 6, and you can multiply by the number of sides. So we have 1, 2, 3, 4, 5, 6. So 6 times 6 equals 36. So that would be my perimeter, and my capital P would be 36. And when we plug it into this equation, we would have area equals 1/2 times square root of 91 times 36. And when we calculate that out, we would find that area equals 171.7 units squared. Another example of the ones that we did when we first learned area, it says find the area of the shaded region. So if you remember the strategy that I gave you, if you find the area of the whole entire thing, you can subtract that off the non-shaded, or basically subtract off what you don't need, and it will leave you with what you're being asked to find. So this whole shape right here is a rectangle. So we can take 20 times 18 equals 360. And then if you look at the shape of the non-shaded, that's the regular polygon, the area of the regular polygon is 1/2 times the apothem. So if you look up at my picture, I see here's a segment from the middle, but this is to the corner. So I'm going to draw in my own apothem, and it's going to make a 90-degree angle. So here's our apothem that we're going to draw in. And remember, the apothem bisects these pieces as well. So I'm going to need to do Pythagorean theorem to figure out the length of my apothem. So from here at the top is 20, and if this is 2 and this is 2, that means this segment that's left over is 20 minus 4, which would leave us with 16. So that means the length of all the sides in the regular polygon are 16, which means half of 16 is 8 and 8. So I'm going to do Pythagorean theorem. So we have 8 squared plus x squared equals 10 squared. So when we solve for that, we're going to get 64 and 100, and we'll end up finding that x squared equals 36. So x equals 6, so we can put 6 up here. My apothem being x, so that means right here our apothem is 6. So the area of the regular polygon is going to be area equals 1/2 times the apothem, which is 6, times the perimeter. So one of the sides is 16, so I'm going to take 16 and multiply it by how many sides there are, which is 5. So we take 16 times 5. And when we do that, we're going to find that our capital P will end up being 80. So we're going to have 1/2 times 6 times our 80. So if we figure this out, 6 divided by 2 is going to be 3. So now we have 3 times 80, which equals 240 units squared. The directions are asking for the area of the shaded region. So if I take the whole entire area, which we figured to be 360, and I subtract off the non-shaded, which was 240, then we would find that we would be left with 120 units squared would be our area of the region that we were looking for.